جراحية ولا أي شيء، كان عبارة عن إنجاز عظيم. هاي هي كانت محاضرتنا الأولى، وإن شاء الله تكونوا استمتعتوا. بنترككم بس عند هذا الفيديو، والسلام عليكم.
If you think about it, CT scans are really quite awesome. They allow you to see inside the human body without cutting it open. Like, imagine if someone asked you to look inside a room, but not to open the door. That's effectively what a CT is doing. But the question is, how do they work? If we cut open a CT scanner, you can see that the inside is just an X-ray generator and detector spinning really fast in a circle. The X-rays travel through your body and get absorbed or scattered by your different body parts. This is called attenuation. You can think of it like how much the X-rays are being blocked from reaching the detector. Materials that are dense, like bone, have a high attenuation coefficient, so block more X-rays and appear white. Less dense materials, like your lungs, have a low attenuation coefficient, so let more X-rays pass through and appear black. So when you're looking at a radiograph, you're actually looking at a
هاي
map of
الأرقام اللي بنحكي
attenuation
عنها مش
coefficients.
فاهمينها،
On the
إحنا
right,
حولناها من
corresponds to the total
من
attenuation
الأرقام إلى
of
جري سكيل زي ما إحنا
every
شايفين شباب.
part of that X-ray. Now, the aim of the CT scan is to reconstruct the values of those attenuation coefficients for the tissues that the X-ray beam passes through. It does this
هاي
by
حطينا
shooting a narrow beam
الكوليمتر.
of X-rays to image a small slice of you at a time, and then stacking those slices at the end. We can simulate this with a 3x3
هاي
grid
المعادلات، وراح
representing
نشرح
a single
الفلتر باك
slice of the
بروجيكشن
human you.
هون.
Just imagine you have something like bone in the center of the image, which is a high attenuation coefficient of, say, 30, and everything around it is just empty space with an attenuation coefficient of 0. If we get an X-ray from this angle, we get total attenuations along these paths to be 0, 30, and
هذا
0.
بسموه
And
الفرونت
this process is
بروجيكشن
forward projection. It's just taking a
أو
simple
فورورد
X-ray.
بروجيكشن
We
عفوا.
keep doing this forward projection for multiple different angles, and we get all these values. Now, say we didn't know what the values in the table were. How do we figure them out? Well, we do something called back projection, where we spread out the total numbers across the
هاي
table.
الباك
So we
بروجيكشن
take
رجعهم
30
مرة
and the
ثانية.
zeros, spread it evenly across the row like this, and then do the same for all the other different angles. You can see how this creates a decent representation of our original image, where the center is a high attenuation and the edges have a relatively low attenuation. So it's a similar concept in CTs, except the image is 1024 pixels wide. Okay, so let's see this in practice. Say we have this image here. It's supposed to represent a brain that's been sliced axially, and just pretend that we don't know what the inside of this image looks like. So we need to put it through a CT scanner to find out. We take X-rays at multiple different angles, and then spread out the result across the image using back projection
أي
like
كل درجة
earlier.
عماله بيعطي
As we get
اتنيويشن
more
في أكثر من
data from
درجة
different
عماله بيسوي
angles,
عشان إيش
now
أعرف
we get
شو
closer,
حل
closer to our
المعادلات اللي
original
كنا
image.
نحكي عنها، بس
And
بطريقة
bada
أخرى
bing,
اللي
bada
هي
boom, we can
اسمها
get
فلتر باك
a
بروجيكشن.
blurry image. Why is this? Well, back projection
راح ينتج
isn't
عنها
100%
البليرنج
accurate.
اللي احنا
There's
شايفينه.
uncertainty in
فدخلت
localizing
بالفلتر عشان
boundaries of
أعرف
three
الباك
frequencies.
بروجيكشن،
And you
فبيطلع
can see
معي
that
المصطلح اسمه
earlier in
فلتر
our
باك
online
بروجيكشن.
grid. To understand
مش
why,
ضروري نحكي
we have to
عنه هسه،
first
راح نحكي عنه
understand that
لقدام
these
شوي.
images are actually
بس هيك
just
نشوف
made
كيف
up
بتشتغل
of
السي تي،
waves.
عبارة عن ويفز بالأخير
I found
وبيحللها.
this really cool simulation on MATLAB.
هاي
You
هون
can see how this
بديفرنت
image is being split up
انجل
into a set of
لا
black and
تقريبا
white
قدر
single
يحصل
waves like
الصورة اللي
this,
بده
each
إياها.
with its own frequency. Splitting up an image or a signal into its constituent frequencies like this is called a Fourier transform. The Fourier transform is a super important mathematical function that pops up almost everywhere in physics and engineering. The most important takeaway from this is that the low frequency waves in our image gives us our large, broad structures, and the high frequency waves gives us the edges and the finer details. Now let's get back to our CT image. The problem with back projection is that we oversample the low frequencies and we undersample the high frequencies, which results in a blurry image. So to get around this, we apply something called a high pass filter to our signal, which, as its name suggests, lets
هون
the high
دخل
frequencies
الفلتر.
pass through and reduces the intensity of lower frequencies. And side note, the high pass filter is usually applied to the signal obtained at the detector way before the back projection step, just because it's faster and easier that way. So we do a back projection of these filtered signals, and bam, we get a sharper image, which is pretty close to the original. And interestingly, when you edit a photo and increase its sharpness, your computer's doing a similar thing. It's performing a Fourier transform, and applying a sort of high pass filter to the image. And if you're doing a Gaussian blur, then you're doing the opposite by applying some sort of low pass filter. This is all well and good, but there are actually better ways to create a CT image. It's called iterative reconstruction and is basically a guess and check method. Again, say we have this simplified slice of a brain which we're putting through a CT scanner and trying to reconstruct. In the first iteration, you start with a guess of what the final image looks like. This can be a decent guess made from back projection, or as simple as a blank image, like in this case. The next step is to do a forward projection of our estimate at multiple different angles like before. But this time we stack all the different X-rays on top of each other to form something called a sinogram. You can see what I mean here. It's called a sinogram because it's forming these sine waves. Then you shoot X-rays through the actual patient in the CT scanner and get the measured sinogram. The aim is to get our estimate sinogram to look like our measured sinogram so that we can reconstruct what the inside of the patient looks like. We do this by dividing the measured sinogram by the estimated sinogram to form the ratio sinogram. The ratio sinogram is then back projected, and the result is multiplied with our initial estimate to form our new guess. Whew. So that's one iteration. And watch what happens with subsequent iterations. The idea is we get closer and closer to the true image until further iterations make no difference to our estimate. So what's the difference between this method and filtered back projection? Well, amazingly, this guess and check method produces higher quality images at the same radiation dose. You can see in this comparison here. The only downside is that iterative reconstruction takes a lot of computing power and time. So up until recently, filtered back projection was the industry
تقريبا
standard.
الفلتر باك بروجكشن
Now,
كانت
with one
افضل
tool,
عشان
such as
الكمبيوتر
fast and
بتحمل.
powerful,
بس
method
الايتريتيف
reconstruction has
ريكونستراكشن كان
become the
مشكلته
norm.
ايش؟ بده
So with
مقومات
dots, what
للكمبيوتر عالية
we
جدا.
do with one
بس
slice
هسه
that we
كلها
can
العلم
body,
تطور، صار
you need to
الايتريتيف
repeat this
ريكونستراكشن هو
whole
اللي شغال.
process for the rest of the slices in the body part you want to image. Then you can stack all those slices on top of each other and the radiologist can scroll through it. You can also do something called multiplanar reformation, meaning you can scroll through the images
هذا
in
النيو
different
ماشين طبعا
planes.
كلياته اللي هو المالتي
You can also do
سلايسنج.
fancy 3D reconstructions,
صارت
and you
مجرد
can even
كبسة
print out
وتحصل
these
الامور هاي
3D
كلها.
models. At its core, CT reconstruction is an inverse maths problem, meaning we have a set of observations and we try to define the factors that led to those observations. Inverse problems crop up in a lot of other places. For example, when you use a photo editing program and remove an object, the software is trying to solve an inverse problem by trying to figure out what was behind that object. And it all comes down to a bit of maths, which is why I find CT so fascinating. Sure, the maths you learnt at school seem boring and pointless, but it's this math, things like algebra and calculus, which helps us look inside people without needing to cut them open. If you think about
الله يعطيكم العافية. إن شاء الله المرة الجاية راح نحكي عن الجنريشن. بانتظاركم المحاضرة الجاي، إن شاء الله تكون المحاضرة ممتعة. تأخرنا عليكم وأسفين، سامحونا. بانتظاركم يوم الاثنين القادم إن شاء الله تعالى. السلام عليكم، يعطيكم العافية.